Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss spot checking of classification algorithms. Spot checking is a way of discovering which algorithms perform well on your machine learning problem. One must try a number of methods and focus attention whose performance is best on the given dataset. Two linear machine algorithms which we can consider for the classification problems are logistic regression and linear discriminant analysis. Logistic regression assumes the Gaussian distribution for the numeric input variables and can model the binary classification problems. Linear discriminant analysis or LDA is a statistical technique for binary and multi-class classification. It too assumes a Gaussian distribution for the numerical input variables. Now let's see how we can carry out this in Jupyter Notebook. From pandas import read underscore CSV. So it will be able to read the CSV files. From sklearn.model underscore selection import kfault. From sklearn.model underscore selection import cross validation score. From sklearn.linear underscore model import logistic regression. Now we will consider the data set which is Pima Indians diabetes. This dataset is very easily available on Kaggle website or UCL repository. We'll specify the file name and specify the path where this data frame is located. These are the names of the variables. Data frame is equal to read underscore CSV. This is a file name which will come from here. Names is the names of the variable. Array is equal to data frame dot values. X is equal to array colon applicable to all rows 0 to 8 variables. Y is equal to array colon comma 8th variable. Num.folds is the 10 folds cross validation is to be carried out. So kfold is equal to kfold, number of splits are 10. Random state is 7. Basically, we are specifying the seed as 7. By specifying this seed, we will be in the position to reproduce the same results. Shuffle is equal to true. Model is equal to logistic regression. Results is equal to cross validation score model, which will come from here. X, Y, and CV is equal to kfold. Print results dot mean. Our algorithm, which is logistic regression, is able to classify the data with the 77.6% accuracy, which is considered to be quite good. Now let us run another algorithm, which is linear discriminant analysis. Everything else remains same. The only thing the change which will happen here is instead of logistic regression, we'll be running linear discriminant analysis. And in this case, we got the result which is 76.69%. Now there are 4 non-linear machine algorithms. The first one is knearest neighbours, 2 nearby's, 3 classification and regression trees, 4 support vector machines. In case of k-nearest neighbors algorithm or KNN, it uses a distance metric to find out the k most similar instances in the training data for a new instance and takes the mean outcome of the neighbors as the prediction. Basically, they are non-linear algorithms. Nearby's calculates the probability of each class and the conditional probability of each class given each input values. These probabilities are estimated for new data and multiplied together, assumed that they are all independent. When working with the real valued data, a Gaussian distribution is assumed to easily estimate the probabilities for input variables using the Gaussian probability density function. Classification and regression tree, popularly known as CART or just descent tree, construct a binary tree from the training data. Split points are chosen greedily by evaluating each attribute and each value of each attribute in the training data in order to minimize a cost function, also known as a Gini index. Support vector machine or SVM seek a line that separates two classes. Those data instances that are closest to the line that best separates the classes are called support vectors and influence where the line is placed. Support vector machine has been extended to support multiple classes. Of particular importance is the use of different kernel functions via the kernel parameter. A powerful radial basis function is used by default. Now let us see how we can do this in Jupyter Notebook. Now in this case, KNN classification, everything else remains same. Instead of model, In case of previous one, we had used logistic regression. Here we will specify k neighbors classifier, and the classification accuracy is 71%. So this is a KNN classification. Everything else remains same. If we want to do the Gaussian naive Bayes classification, all other things remain same, and here the model will be Gaussian NB. And here we got the classification accuracy which is of 75.91%. If you want to carry out the card classification, all other things remain same. Make sure that if you are using KNN classification, you will have to import its library, and therefore make sure that you import K neighbors classifier. If you are using Gaussian naive Bayes classification, make sure that you import its library Gaussian NB. If you are using card classification, make sure that you import its decision tree classifier. Then specify the decision tree classifier model, and you got the classification accuracy which is 69%. If you are using support vector machine, make sure that you import the support vector classification library. And here you specify the model which is SVC. So here also you got the classification accuracy is 76%. Now, which algorithm to use? Normally, we should go for logistic regression because it is a simple algorithm and its interpretation is quite easy. Moreover, you can see that the classification accuracy which we are getting in logistic regression is 76.6%, which is a linear algorithm, and therefore, according to the Occam's razor, if we can explain the phenomena with the simple model, we should always start with the simple model rather than using the complex model. So the linear model should be always preferred over the non-linear models if your classification accuracy is more or less nearer to each other. All these codes are given in the book Machine Learning Mastery with Python, written by Jason Brownlee. You can refer my playlist in which I have already uploaded many videos which are related to machine learning using Python. You can subscribe to my channel. You can also follow me on LinkedIn and Twitter. Please don't forget to press the like button.